Welcome back, everybody. Today's lesson will be about functions, lambda functions, higher order function. And today is actually the fourth week. So I can call it week 4. And then let's write what we are going to learn today. Notes.txt. What's that? I think I was a bit quick, or my keyboard is jumping. So what did we plan to cover today? I will take you to 30 days of Python, and let's plan first. So last week, what we planned is actually to learn about functions, list comprehension, higher order function. Those are actually the main lessons we would like to cover. And in addition, something that we didn't cover so far is actually set and tuples. And before that, even I think it would be good to actually finish the different data structures. That's the tuples and sets are not yet covered. So then maybe it's a good idea to start with set and then we move on. So I can create and sets.py. In here, we will learn about set. So what is this set actually? It's a different kind of data structure that allow us to create a set. So for instance, something like this, and then I can say set. So this is the way we create new or an empty set. So let me print this out and see the value. Okay, as you can see, it's just something like this. Oh, then how about if I want to just have more value, maybe instead of empty set, if I want to create like a set with value, maybe I can say 1, 2, 3, 4. And let's see. Yeah, 1, 2, 3, 4. Can we check the lengths? The lengths, and then you just say it's S, and then let's see, I'm expecting 4. Oh, can we check the data type of S? And let's see. As you can see, it's actually a set. That's great. But what's the purpose of set? What's the purpose? We have already actually a list. And why we need this? Because this is useful to remove duplicates, or it doesn't store duplicate data. Let me, for instance, add additional 2 and maybe additional 4. Actually, these duplicates will be removed. Okay, then I'm expecting still the length will be 4. As you can see, it's still 4. And the output is actually 1, 2, 3, 4. So the, what is this? The duplicates has been removed. Yeah. How do we add then? Maybe can we add on this? We can add actually s add, and then we can add maybe 5. And then if I print now the set, you will see that 5 has been added. Yeah. Okay, I don't remember all the different set methods, so I would like to use the cheat sheet we have here. So as you can see, we have created something like this. That's an empty set. So creating a set with some items or some values, curly bracket, and the items, as you can see, item 1, item 2. These items could be value of different data type. For instance, here, a set of fruits, banana, orange, mango, and lemon. Yeah, getting the lengths, actually, you just, as we did, lengths and the set. ST represents set of this. So I'm expecting from this, for instance, item 1, item 2, item 3, item 4. They are different items, so the length is gonna be 4. In this case, also banana, orange, mango, lemon. So they are unique, and then so it's going to be 4. Accessing items in a set. Okay, it's almost like a list. So we can say item 3. Yeah. For instance, I did this. It's an explanation. So banana, orange, mango, and lemon. Can we have do we have mango in this? Yes, we do have actually mango in here. Yeah, so it should be true. Adding items, we use the add method. The add method. As you can see, banana, orange, mango, lemon, and now we are adding lime. So after this operation, we should have lime in this set. Oh yeah, with add, you can only add one item at once, but with update, you can add multiple items to the set. For instance, here, I can say S update, and then I can actually, maybe I can say 6, 7, 8, 9. And then if I print here, print S, and then it will be like 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So we can, is it only something like this? I think this could be anything. It could be a list, or it could be a set, or it could be a tuple, or it could be anything. For instance, if I change this to a set, let's try. And then we should get, this should be also. Yeah, we should get the same value, as you can see. How can we make this a tuple? Can it take tuple? If you change this, tuple is with a curly, with this parenthesis is a tuple. We are going to learn about tuples. So yes. And then as you can see, update allow us to add more items, removing. So that means we can remove, as you can see, remove and the item we like to remove. So for instance, if I want to remove something, remove, and then I can remove, for instance, 7. And then after that, if I print the set, there shouldn't be any 7 in the set. Okay, let's move on. So the pop methods remove random item from a list and returns the removed item. Why pop random item? Because this set doesn't have any order. It doesn't have order. If you remember, list has order. So by index, but this doesn't have any order, and index cannot be applied here. There's not the so-called indexing, and there is not the so-called ordering. That means we cannot say this one is first, and this one is second, and this one is third, and this one is last. There's no the so-called order here in a set. Okay, that's great. Clearing items in a set. That means completely removing. So we can just use the clear method, s.clear. And then if you print after this, we should get actually empty set. Empty set. Yeah, that's an empty set. Okay. Delete. We can also delete the whole set like this, delete and the name of the set, the variable here. Delete fruits, and then this will remove totally the fruits set. Converting list to set. Okay, yeah, that's so easy. We can just convert this list, to list, and then S, something like this. Then if I print out the list, I should get the list. But here, since I cleared out everything, I should stop that from there. And then as you can see here, actually, I converted this set to list. Yeah. Of course, it's a kind of one-to-one correspondence, but there is a different data structure. This one is set, and this one is list. And the list has got an order, yeah, and it has got an index, but this doesn't have any kind of order. Joining sets, we can join. Okay, maybe from elementary school, we have this different kind of set operation, right? If there's A and B, we can say A union B, A intersection B, right? And maybe A without B, or maybe B without A, and maybe A delta. How do I write delta here? Maybe delta B. That means the symmetric difference of A and B. That means A without B union A with B without A. Yeah. So let's create set A, right? Set A is like 1, 2, 3, 4, 5, 6. And set B, let's see, 2, 3, and 4, and 7, 8, 9, and then that would be enough. Okay. Now, can you tell me, just because I want to know if you remember A union B. Can you tell me A union B values? 1, 2, 3, 4, 5, 6, 7, 8, 9. Union doesn't allow duplicates, right? It takes all the items in here and all the items in here. Okay. Do you agree? Any objection here? Okay, no objection.
I
Then
think,
A
sorry,
intersection.
sorry to interrupt you. I think you should, in row 22, there should be B, no S.
Oh,
Yes.
thank you. Thank you so much. I didn't see that. Yes, A intersection B. And then intersection B, let's see the common element in here and here. 1, no, 2 common, 3 common, 4 common, and there's nothing else. So 2, 3, and then 4. Then let's do A without B. A without B, I think that they call it a complement. A without B, I can just write it A without B. I think the value will be 1, 5, and 6. 1, 5, 6. So values only, A without B means values only in A. Do you agree? B without A. And then that means all the values that exist only in B, I can say 7, 8, 9. 7, 8, 9. Okay, then the symmetric difference actually A, this A without B, union B without A. And then let's see. So that means these two, the union of these two, it's going to be 1, 3, 6, 7, 8, 9. Yeah, that's great. So now we did it manually based on our previous background from high school mathematics education or something. Now let's leverage the power of Python to solve this, right? Then I can just say print A dot union, there's already a method B, or B union A. So it's because it's commutative property. So from this, I'm expecting this value. Okay, let's see. So as you can see, we don't know what this is actually. Then I think it's better if I say, let's see, some kind of A union B. And of course, if I put comma here, then it would be easy for me to know what that is. A union B, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, I think that was right. Then print A intersection B. And then A dot intersection B. And then I should get the same result here, 2, 3, 4. That's great. And then print A without B, and let's see. That means A difference B. A difference B is different from B difference A, so that's not commutative. So I can say B. And as it 1, 5, 6, 1A without B, 1, 5, 6. Yeah, it should be. This is not 3, guys, because 3 exists in here. So we should have, it should be like that. Yeah, Python helped me to correct my mistake, but you didn't, right? Okay, then let's move on. Print B without A. So if that's the problem, then I think there's a problem here. I have to also fix this to 5, because that problem also goes here. A without B, the A without A, B without A. It's so easy, as you can see, just difference, and then you pass B here. But the problem is actually this should be B and the other is A. Yeah. Oh, why is that? Great. As you can see, B without A, 8, 9, 7. Okay, we're left with this, the symmetric difference. I can copy this because writing that's a bit something like that. Then comma, what we should do, actually A symmetric difference of B. As you can see, these methods, they already exist. It's not something we write, right? So let's see. 1, 5, 6, 7, 8, 9. 1, 5, 6, 7, 8, 9. So can we check if A is a subset of B? A subset? No, A subset. Why is that? Is subset, yeah. Is super subset or set? Is, I think it is superset, yeah. Is A a superset of B? No, they are not super subset of each other. As you can see, it should be false. If I say print A dot is disjoint set. Disjoint set means if there is no common value between A and B, that means disjoint set. Disjoint sets are sets, that doesn't have common value. As you can see, it's false. So all the set and the logic property you learn in mathematics exist in Python. I think that's good enough already. We don't have to just go match. I think find intersection, checking subset and superset. As you can see, is subset and is super subset. And you check the difference between two sets. Difference, that's the actually A without B. And find symmetric difference. We have checked that. Also, joining sets is joining. That means it's another way if they have intersection or not. So for your surprise, I think this is good enough about set. But maybe I can show you the use case, yeah? So now I have a sentence here. I call it, I love teaching, and there is nothing like teaching. Because of the love of teaching, I will teach all the time. Do you love teaching? What do you love? I'm just, creating a story here. So as you can see, this is a chunk of text. So it's a string. Now let's count the number of words here. Number of words. Number of words. And maybe number of unique words. Number of unique words. Yeah. And then maybe we might be interested in the lexical variety of the sentence, right? Lexical variety means like the uniqueness. Are we writing the same thing over, what is this? Over and over again? Yeah, please, someone got a question, yeah?
Yes, I have question. Sorry, before like moving onwards, but in the terminal, it's written. It's a bit dumb question, but I just maybe want to make sure. It's written B without A in the terminal. Why is it 897? Why is not going like from the lowest to the top?
It doesn't
I'm just
have
curious.
yeah,
What's the logic behind
set.
in the
Okay,
terminal B without A?
Oh, yes.
8, 9.
It's just like this. It's just chose to put it in ascending order, but it doesn't have order actually. Just for a display, it just displayed it here in ascending order 8, 9, 7.
But we could define like to do in ascending order, I guess.
No, you don't have to. Not
Okay.
really.
All
can,
right.
and the data never comes also whenever, for instance, like imagine you create an empty set, and the purpose of creating an empty set is to collect some data at different times. So the data that comes may have a different value, so you don't have to really worry about the ascending or descending. And the purpose, the reason why we need also set has its own purpose, that's just to remove duplicates. When it comes to order, there is a different data structure, and that is list. List will take care of this kind of ordering stuff. So you don't have to really like put this in order or no. You can just put it in any order you want.
Thank you.
So now lexical variety. Now let's see how can we change this to words. I think you know what I should do first. Maybe I can also add one word. Love is a great thing to have, okay? Now, I want to change that to words. So what I should do, just words and then sentence. I want to just lower it first, just to lower. And maybe if there's some space in this, maybe you can strip, but there's no in this case. And if there is also full stop, you can replace all the full stop with nothing. And let's see what we have so far, okay? Print words, because it's good to just see what's happening at it. Yeah, it has been lowered and all the punctuation mark has been removed, but still we have this question mark. I can also replace the question mark with nothing, and now let's replacing this nothing. So as you can see, now I have only text. That's good. Then I think it's a good time to split. And the split, if you can do like this at space, and you can see what you will get, something like this. Or by default, also if you don't pass actually that, you get the same thing, something like this. So what we got is actually list. So to answer this number of words, so the number of words are actually lengths, just then words. Yeah. So if you are asked what is this, I can see this. Yeah. Okay. Yeah, that's coming from It's the list. So the number of words are 35 words in this text. For instance, if you are asked to calculate the number of words in the message you send, or maybe in some, I don't know, in any text, okay? This is how you calculate. But now, number of unique words. You may already think that this got teaching, and then teaching, and then teaching, and then again teaching, and then lab everywhere, right? So it should be removed. So how can we remove that? Unique words, okay? And then I can say set, and then I will pass the words. As you can see, I'm changing actually the list to set. And then now let's see, print uniques, unique words, and at the same time, the length of the unique words. Okay. Oh yeah, 23. Yes. So I think almost 17. How much? Actually 12. About 12 words are actually like got like more than once. Okay, now the lexical variety, like how can we calculate it in percentage? So print, yeah, the unique words divided by total number of words, the length of the words, multiplied by 100, and then that gives the lexical variety. Lexical variety means the different, actually, what is that? Why? Yeah, I think I did. Yes, unique words and length of total unique words. Then length of unique words, and then total words, length of words. Then I don't have to just unique total unique words divided by total words multiplied by this, and then as you can see, we got 65%. Yes, maybe as you can see, there is too much number after the decimal, so it's better to chop off. So I can say 1 digit would be enough. Yeah, 65.7%. So there's some kind of variety, but not very different. So I was like making or using the same word love again and again, just to show you, to demonstrate this lexical variety. Do you have any question? So as you can see, the main purpose of set is actually to remove duplicates. Then if you don't have any question, let's finish set in here.